Good mornings to all my panels and supervisor. Before I start, let me introduce myself. My name is Kugan Tamil Kumar, Matric number B0517100163. The title of my project is Development of Keyless Entry System for Lever Handles. The problem statement is many approaches have been proposed and applied to replace the traditional key to unlock the entry system. The rate of technological is increased with time. Society is looking to create and develop an easier way to live and manage their daily tasks. The new FKP office of Universiti Teknikal Malaysia Melaka UTeM is using new doorknob that is level type and is using key for lock and unlock the door. To reduce the usage of metal material, we propose a remote monitoring system of keyless entry system using mobile application to easily open the doorknob without using the key. The objective of this project is the study on the remote monitoring and control of keyless entry system seeks to attain the following objective. The first objective is to design and develop a motorized attachment for the keyless entry system. The second objective is to design a mobile application for control the keyless entry system. The third objective is to evaluate the functionality of keyless entry system. The methodology. This is the flowchart. The first step is to create the conceptual design. If the design is selected, we proceed to design the system. After design the system, we develop the prototype. Then we configuring BLYNK app. If we successfully create the BLYNK app, we proceed to programming the ESP8266. After we successfully coding for the ESP8266, we run and test the system by using 6 different conditions. The conceptual design sketches. There are 4 sketches. The first concept A using the linkage mechanism and the power supply is battery. We use different types of design in this linkage mechanism. Concept B, we using sketch chain and gear mechanism. They are also using power supply but by using solar. The third concept is leakage mechanism, but this is different with the concept A. This is using a different linkage, that is the support is only at the bottom. Concept D is using belt drive mechanism. This power supply is battery. If you see this concept got belt and the drive system to run the system. After do the 4 concept, we do the concept screening for the 4 concept. We can see we create a table for 4 concept and select the best concept for the project. The concept A is selected as the rank 1, that is the linkage mechanism. So this concept is continue for the project design. Design of system. This is the design that I create by using CATIA software. This is the full 3D design that we can see in this picture. The manufacturing process that involved in this project is, there's only one process involved to produce the lock buttons cover, motor holder and linkage mechanism. For the linkage mechanism, need 3 linkage to join the motor holder and the door. The 3 linkage consists of 2 linkage without hole and 1 linkage with hole. The linkage with hole is to use the servo motor wire to go through it to ESP8266 VMOS D1R2. The process that involved in this prototype is 3D printing. The material that we'll use is PLA filament. PLA is a polylactic acid. The sub parts in the system, just now I say they got the lock buttons cover, the servo motor holder, linkage without hold and a linkage with hold. This is the design that created by using the CATIA software. This design will proceed to the 3D printing and produce 4 products with a different quality and the different quantity. The L3 components. The L3 components, there are 3. One is FS5115M servo motor, then battery AAA 6RLR61 ultra alkaline battery, of course the Wi-Fi module, that is ESP8266 BMOS D1R2. This is the 3 L3 components that I use in this project. The servo motor. The servo motor is used analog RC servo. The gear type is metal gear. The weight is 58.5 gram. The dimension is 40.8 times 20.1 times 38 millimeter. Operating voltage is 4.8 volt to 6.0 volt. The spec for 5 volt, because in this project the servo motor is supplied by 5 volt. So the no load current is 165 milliampere. The stall current is 1250 milliampere. The speed is 0.176 second per 60 degree. That is equals to 5.95 radian per second. The stall torque is 14.25 kg centimeter. That is 0.1425 kg meter. The power consumption is calculated, that is torque times with the omega, that is the angular speed. So the power equals to torque times with omega. The torque is 0.1425 kg meter. The times with the omega 5.95 radian per second. So we can get 0.848 watts. That is the power consumption of the servo motor. Next is the battery. The AAA 6LR61 ultra alkaline battery. They use as a power supply for the ESP8266 BMOS T1R2 to control the servo motor. This battery's dimension is height is 45, length is 25 mm, the width is 70.2 mm. The battery is using direct current. The direct current is suitable for the power supply for the ESP8266. The specification of ESP8266 BMOS T1R2 is using micro USB to transfer the coding from the software. Is compatible with Arduino, scheduling for USB. The microprocessor is used is ESP8266EX. The voltage is 3.3 volt. One input pin 3.2 volt maximum. Frequency 8 MHz to 160 MHz. Flash memory is 4 megabytes. Dimension is 68.6 mm times 53.4 mm. The weight of the module is 25 grams. All terminal input and output operating at 3.3 volt. In this module, I use the ground pin, the digital pin 8 and the 5 volt output to give signal and power supply to the servo motor. The next is BLYNK cap. This is a BLYNK cap that we can install in any smartphone. First, we need to install the BLYNK cap in the smartphone, and we need to download the BLYNK library 1.0.0 version and install in your PC. Set the right port of the PC to communicate with the ESP8266 BMOS D1R2. Update the out token in the sketch and upload it to the Arduino IDE software. For connecting your Arduino with the internet shield to the internet, run the BLYNK on the smartphone. The Arduino IDE, the coding created by using Arduino IDE. This is the coding that I create by using the software. The first, we need to install the 3 library that is for ESP8266, for the BLYNK and for the servo motor. They are the function and the looping in this coding to run many times as we can in the system. The char out we can get from the BLYNK app. The char access ID is the Wi-Fi ID. The char pass is the password of the Wi-Fi. This is the result after the project is done. This is the attachment that done. By doing this, I already obtained my objective 1 and objective 2. Okay, now we need to lock of the doorknob. We can see the motto rotate clockwise 90 degree and it cannot open because it is locked. For unlock, you need to click the unlock in the smartphone. So it will anti-clockwise, counterclockwise 90 degree and we can now open the doorknob. Inside the box got VMOS and the power supply battery. This is the BLYNK app that I create by using the BLYNK app in my smartphone. This is the result that I measure by using the multimeter, the output voltage for the lock system. As we see, the average is 4.77 volt. That is a suitable volt for lock the system. This is the output voltage for unlock the system. As we can see, the average reading is 4.87 volt. That is a suitable volt for the unlock the system without any disturbance. The distance for access the system. This is the distance. I already test until from 1 meter to 19 meter. Is still I can access the system. That is proven that BLYNK don't have the limit for the distance. So as my calculation, if the system in Penang and the user in the JB or Johor Bahru, they still can access the system. The duration of battery supply to the system, I test for 1 day. Still the battery is supplied to the system. The duration required to lock and unlock the system. As we can see, the average reading, the time is 2.61 second for lock and 2.31 second for unlock the system. The conclusion is the keyless entry system is useful and reliable system that can be used to lock and unlock the doorknob level type in new FKP office at Universiti Teknikal Malaysia Melaka. As stated in the introduction part, the first objective of this project, that is to design and develop a motorized attachment for the keyless entry system, is successfully achieved by creating attachment by using FS5115M servo motor and ESP8266 VMOS D1R2. As for the second objective of this project, that is to design a mobile application for control the keyless entry system, is successfully achieved by creating a design by using BLYNK app in smartphone. Lastly, the third objective of this project is to evaluate the functionality of the keyless entry system, is successfully achieved by using 6 experiments were carried out under different conditions. The recommendation of future development of this project is the user of the system should be more than one by using the BLYNK app. Then the system should be upgraded and linked to the things of speak to gather more data of the usage by the user to see maybe the time and the location when the user used the system. Thank you.